Welcome back, everyone. Today's deep dive takes us to Singapore. Would you like to know?
Exciting.
Yeah. We've got this website, almost like a time capsule, and it's all about this event, um, eduLab at AST Learning Journey
Okay,
at the Academy of Singapore Teachers, AST.
gotcha.
So this is all about educational innovation, right? And our source, the single website, it's really fascinating. It's all about open source physics in the classroom.
It's interesting you say that because it really captures a moment where teachers were kind of like at the forefront of this whole movement towards open educational resources.
Open educational resources. Now, like listeners who might not be familiar,
Right.
what exactly are we talking about here?
Well, think about it as freely available online resources, so like simulations, interactive models, all these things that teachers can use
Yeah,
to make physics
more engaging.
more engaging, more hands-on. Yeah,
So instead of just textbooks and formulas,
right.
students could actually see physics in action.
Exactly.
That's a game changer.
And the website highlights this one teacher, Wee Lu Kang,
Okay.
who was just like a total champion for this approach.
Using these resources himself in the classroom.
Absolutely. And advocating for others to do the same.
Oh, that's great. I remember physics in school. It was just so
Well,
abstract, yeah, and theoretical. I wish it had something like this.
I know, right? And that's what makes this story so compelling. These teachers, they knew that traditional methods, they weren't always effective.
Right.
And they were actively looking for new ways to make physics more accessible,
Yeah.
more engaging for their students.
So this event,
Yeah.
eduLab at AST Learning Journey, sounds like it was a pretty big deal,
It was.
like a gathering of the mind.
A real gathering. And not just local either. The website mentions international delegates were there, even local media. So Singapore was kind of positioning itself as a leader in this whole movement.
Showcasing their efforts on a global stage.
Absolutely. And it really speaks to how important it was for them to share these ideas, right? And inspire others to adopt similar approaches.
Now let's get into the specifics. The website mentions something called Java applets.
The applets.
What exactly are we talking about?
Well, think of them as mini programs, yeah,
Yeah.
that run within a web browser. And they were being used here to create these interactive simulations.
Oh, cool.
So students could actually experiment with different physics concepts.
Can you give us an example? What would one of these look like?
Sure. One of the applets mentioned on the website, it's called EJS magnet falling, etlslpoil.jar. Even the name itself kind of tells you what it simulates.
So we've got a magnet,
Magnet, right?
a coil. What's going on?
It probably simulates the phenomenon of electromagnetic induction, which, is a pretty fundamental concept in physics.
How would this applet be any better than just reading a textbook explanation?
Well, imagine you're a student. Instead of just reading about this, kind of dry concept, you can actually see it happening right there in front of you.
Okay.
You can, manipulate the strength of the magnet, the number of coils in the wire, see how these changes affect the induced current.
So you're interacting with it.
Absolutely, making the theory come alive.
That's pretty amazing. It sounds like these teachers were,
Ahead of their time.
yeah. But the big question is, did their efforts have a lasting impact? Did it spread beyond just physics?
That's a great question. And that's what we'll be exploring next time we continue our deep dive.
Welcome back to our deep dive into open source physics in Singapore. Last time we were talking about Wee Lu Kang and all his work with bringing these interactive physics simulations into the classroom.
It's incredible. He really was a pioneer in this whole movement.
Using these free online resources, making physics more engaging.
Totally. And more accessible, too.
Yeah.
For students who might have struggled with the traditional.
Yeah, right. And we were just starting to talk about those Java applets, the little programs behind the simulations.
Right. Those are really key to understanding how this all worked, in practice. Because they weren't just simple animations, right?
Okay.
They let students change variables, do experiments, really get a feel for how the physics concepts played out in this virtual environment.
That's so cool. And you mentioned the EJS magnet falling LT/else coil.jar, right?
Yeah.
Simulating electromagnetic induction. But there were a whole bunch of others
Oh, ton.
with these crazy names.
I know, right?
What else did they have?
Let's see. There was one. EJ's Kepler system third law 01.jar. Now, what do you think that one's all about?
Okay, Kepler. That's got to be planets, right?
Planets.
Orbits and all that.
Exactly. Probably simulates Kepler's third law of planetary motion,
Okay. I vaguely remember that from school.
which is all about the relationship between a planet's orbital period and its distance from the sun. Pretty complex stuff.
So instead of just memorizing the law,
Right.
students could actually play around with it, see how changing the distance affects the orbit.
Exactly. And that's where the real learning happens, right?
Yep.
It's one thing to, like, understand the concept intellectually, but to actually see it in action, be able to manipulate the variables yourself.
It becomes real.
Yeah.
I'm starting to get why this approach was so revolutionary, taking these abstract concepts, making them
Tangible, interactive.
like a game almost.
Exactly.
And that's huge, especially for physics, which can be pretty intimidating, right, for a lot of students.
You mentioned these applets were hosted on a Google site.
Yes.
Is that just for downloading them? Or
It was much more than that. Like, think of it as a hub for everything related to open source physics in Singapore.
oh wow.
Teachers could find not only the applets, but lesson plans, teaching materials, research articles even, all about using simulations in education.
So, like a one-stop shop for
Absolutely, yeah.
incorporating this approach. And it really highlights how important community is to this whole movement. It wasn't just individuals working alone.
Right.
They were sharing, collaborating, learning from each other.
Makes sense. Even the most innovative teacher would benefit from
Oh, absolutely.
having that support.
Yeah, that community. And it wasn't limited to Singapore either.
Oh.
The website talks about presentations at international conferences, collaborations with educators in other countries. This was like a global effort, to transform physics education.
This is all so inspiring. But
Yeah.
did it work? Do we know if these methods actually led to, like, better learning outcomes for students?
That's the million-dollar question, right?
Yeah.
That educators and researchers have been trying to answer for years. And this specific website doesn't give us, hard data on student performance.
Okay.
But there's a ton of research out there that suggests simulations can be incredibly effective learning tools.
Really?
Oh, yeah, especially in STEM fields, like physics.
So we don't have specific numbers from Singapore classrooms,
Right.
but we can look at the bigger picture.
Exactly. There are studies that show using simulations helps students visualize abstract concepts, improves their problem-solving skills,
That makes sense.
even increases their motivation and engagement.
If you can see how it works instead of just reading about it,
Yeah.
of course it'll be more engaging.
And that's, like, one of the key takeaways here, right? It's not just about the tech itself.
Right.
It's about how we use it to create more effective and engaging learning experiences.
It really is amazing how forward-thinking these teachers were. Back in 2012, embracing open source, experimenting,
Have occurred.
long before it became mainstream. So
Yeah.
what happened next? Did these efforts have a lasting impact? How did this movement evolve?
That's what we'll be uncovering in the final part of our deep dive. We'll explore the legacy of these initiatives and how they continue to shape education today.
It's really something, isn't it? These teachers in Singapore, back in 2012, they were already using open source physics interactive simulations, like way ahead of the curve.
It makes you wonder, like, where did it all lead? What happened next?
That's the best part of these deep dives. We get to trace those ripples, see how that one event, one website even, might have sparked something much bigger.
Exactly.
So after EduLab at AST Learning Journey, did this whole innovation thing just fade away, or did it, like, grow into a real movement?
Well, the website's pretty interesting. It's not just a snapshot,
Yeah.
It's got all these hints, breadcrumbs leading us forward.
Oh, I see what you mean. Like those links to presentations and workshops from later years, all building on those early open source physics ideas?
Exactly, like a sustained effort, right?
Yeah.
Spreading those teaching practices, reaching more and more educators. It wasn't just a one-off thing.
Yeah, the start of something that kept evolving.
And there were even mentions of research projects, looking at how effective simulations were in education, which is really important,
Yeah, not just doing something new, but actually trying to understand the impact.
Exactly, that blend of passion and data, right? It's so crucial in education. They weren't just blindly adopting new tools.
We wanted to know if it worked.
Yeah, measure the effectiveness, refine their methods based on evidence.
So we see that initial spark in 2012, and then, bam, more workshops, more research, more teachers getting involved.
And remember, it didn't stop at Singapore's borders. The website mentions collaborations, international conferences.
So those efforts in Singapore, they could have contributed to this whole global movement. towards open educational resources, a more innovative way of teaching physics.
It's amazing how these small, localized initiatives,
Yeah.
they can have a ripple effect,
Yeah.
worldwide. And it really speaks to the importance of sharing, collaborating across borders, learning from each other.
As we wrap up this deep dive,
Yeah.
what are the big takeaways for you? What can we all learn from this story?
For me, it's a reminder that real change in education,
Mm.
it often starts at the grassroots level. It's about individuals,
Yeah.
passionate individuals who are willing to challenge how things are done, experiment, champion a better vision.
And community, right. That's a huge part of it.
Oh, absolutely. These teachers, they weren't working in isolation. They built networks, shared resources, learned from each other's successes, failures even. That's crucial for any innovation to succeed.
So for listeners who are feeling inspired right now,
Yeah.
where can they go to learn more about open educational resources, how to use them?
Oh, there are so many amazing resources online. Just search Open Educational Resources, Open Source Physics. You'll find websites, communities, organizations.
This deep dive has been really eye-opening for me. It's amazing what a single event, a group of dedicated teachers,
Yeah,
how their ideas can spread so far.
it really is. And it reminds us that the future of education, it's not set in stone. It's something we're all shaping, with our choices, our actions, our willingness to embrace new ideas.
If those teachers could make a difference back then.
Think what we can do now, right?
With all the resources, the connections we have today.
Absolutely. So let this be a call to action,
Yeah.
Explore open educational resources, connect with other educators, and be part of this movement. Making learning more engaging, accessible, inspiring for all students.
Thanks for joining us on this deep dive. Until next time, keep exploring.